Hey guys, once again welcome to my channel Unigrabs, the Learning Center. Today we're gonna discuss about maths real number. So let's start. Hi guys, today we're gonna study about what is real number. So real number is a collection of rational number and irrational number that make up the set of real number. So here a question arises that what is rational number and what is irrational number. Rational number are the number that can be expressed as a fraction or part of whole number. It can be any negative number, it can be decimal number, it can be fraction, okay, that can be expressed or that is not infinite, okay, which is finite, that is called rational number. And the irrational numbers are the number that cannot be expressed as a fraction or ratio of two integer, like there is no finite way to express them. So for example, root pi lambda and etc. Okay, so you got the clear thing about rational irrational number, and then is this real number follows some rules or some properties. Okay, so first rule or law is commutative law of addition. Commutative law of addition. Sorry. So in commutative law of addition, what is there? That is when a and b are two real number. Okay, like a and b, suppose a and b are two real number, and what will happen if a plus b equals to a b plus a, then that means a plus b, the whatever the result will come, the same result would come from with the help of b plus a. An example is given here, that is 1 plus 3 equals to 3 plus 1 equals to 4. The commutative law of multiplication, the next one. And that is when a and b are two real number, then a into b and b into a, the result would be same, and the example is given below. Then the next one is the associative law of addition. That is when a, b and c are three real number, then a plus your in whole bracket b plus c equals to in whole bracket a plus b plus c, the result might be same. Okay, then the rule will be satisfied. And then the next one is the associative law of multiplication, and that is same as addition. A into in whole bracket b into c equals to a into b in whole bracket into c, the result might be same, and the example is given here. Then the next one and the last one is the law of distribution. In law of distribution, what happens? A, B, and C, these are real number. Okay, so A into B plus C equals to A into B plus A into C. That is, A can be multiplied with one your B also, and A can be multiplied with C also. That means we can write now like that, that A into B plus A into C, the result will be same only then. Okay, an example is given here. Please, now we will learn about Euclid division. So what is this Euclid division? With the help of this method, we can find out the highest common factor. There is some values of it, like q and r are there for every positive integer, such as a equals to bq plus r, where your 0 is less than equals to r and r is less than b. There is specific name for each term, like a stands for dividend, b stands for divisor, q is quotient, and r is remainder. Okay, so let's see some example of Euclid division. Let's apply Euclid division to two numbers, that is 726 and 275. I have explained step by step in this video. So let's see the first step. 726 and 726 is greater than 275. You can see that, right? So 726 will be your dividend and 275 will be your divisor. So you have to make it like in division. What do? You have to make your result 0 with no remainder, right? You have to make here the same thing. Okay, now in the table of 275, is there 726? No, there is not. Then we will see the nearest one, the nearest value of 726. So it is 550, which is 275 into 2. We will after multiplying with 2, we will get it. Okay. So after doing that, you will get remainder of 176, and we will add it here. Okay, like plus 176. Okay, so we got the remainder 176, and is it equals to 0? So we will see that in step 2 that it is not equals to 0. So again you will see that 275 is greater than 176, so 275 will be your dividend, and 176, which is the remainder, will be your divisor. Again apply the same thing. You have to see that one in the table of 176 is there 275. If it is not, then find the nearest one, add the remainder with it. Okay, see, and that in this your remainder came 99. So 9, is it 99 is equals to 0? If it is not, then 99 will become your divisor, and 176 will become your dividend. Again do the same thing in step 3. See, in the table of 99, is 176 present? No. If it is not present, then find the nearest one, and add your remainder. So your remainder came 77. Okay. Now again follow the same procedure, as 77 is not equals to 0, so it is remainder, so it will become divisor, and 99 will become dividend. Again do the same procedure, add the remainder. Again you see at step 5 that 22 is not equals to 0. Do the same thing again till it comes 0, and in the 6 steps we got 0, right? So our HCF of 726 and 275 is 11, because 11 was the last divisor. Okay, let's see a problem. Here is a question. Here is a question given that show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So let's take a as positive odd integer. Okay, and let's apply the division algorithm here. Okay, so a and b equals to 4. Now here a question arises that how 4 came. Now 4 came as because we can solve this equation in 4 possible steps. That's why 4 is your b is your 4. Okay, since 0 is less than equals to 4, so less than equals to r is remainder, and r is less than 4, then the possible remainder will be what? 0, 1, 2 and 3. Okay, so we can write this thing according to your problem, that is 4q, how 4q came, like 4q plus 0, then we can write 4q only. Okay, now we are adding the remainders. Okay, and then 4q plus 1, then 4q plus 2, then 4q plus 3, and adding the remainders at the back. Okay, and q is your quotient. Okay, so uh, here in this 4 equations, your odd one is what? 4q plus 1 and 4q plus 3 is your odd one. So 4q and 4q plus 2 is even, and that is divisible by 3. And in our question it is said that we need to find out the positive odd integer. So odd one is which one? 4q plus 1 and 4q plus 3. Okay, so here is your answer. Therefore any odd integer is of the form is 4q plus 1 or 4q plus 3. Your equation is solved. Now let's see in problem sum. An army contingent of 420 members is to march behind an army band of 130 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So we will solve this problem according to Euclid algorithm to find their HCF. Okay, so in the according to question, the greatest number is 420, so it will become the dividend, and 130 will become divisor. So we will find in the table of 130 that 420 is present over there. If it is not there, then we will find the nearest one. Then what is there? If we multiply 130 into 3, then we will get 390, and the remainder will be 30. So we will add it behind this number. So again, what will we do? Again, we will repeat the same procedure. 130 then will become then dividend, and 30, that which is remainder, will become the divisor. Again, we will see in the table of 30, is there 130? If it is not there, then we will find the nearest one. And in the table of 30, if we multiply with 4, then the result will be 120, right? And how much left more? 10 is left, that will become remainder. So we will add it behind it. Again, the dividend will be 30, and the remainder, that will be your divisor. Then we will see again that in the table of 10, is there 30? Yes, it is there. So what is our remainder now? 0. Once your result or your remainder comes 0, your problem is solved. So according to our problem sum, the hi guys, today we're gonna study about what is real number. So real number is a collection of rational number and irrational number that make up the set of real number. So here a question arises that what is rational number and what is irrational number. Rational number are the number that can be expressed as a fraction or part of whole number. It can be any negative number, it can be decimal number, it can be fraction, okay, that can be expressed, or that is not infinite, okay, which is finite, that is called rational number. And the irrational numbers are the number that cannot be expressed as a fraction or ratio of two integer, like there is no finite way to express them. So for example, root, pi, lambda, and etc. Okay, so you got the clear thing about rational irrational number. And then is this real number follows some rules or some properties. Okay, so first rule or law is commutative law of addition. Commutative law of addition, sorry. So in commutative law of addition, what is there? That is when a and b are two real numbers. Now by taking cube of all the three above expression, in our case we get number 1, in our first case r is equals to 0, then our expression is 3q for x in this case. So if we convert x as x cube, then 3q will be 3q whole cube. So the result will be 27q cube. And taking 9 common from it, we get 9 whole to the power 3q cube. And let's take 3q cube equals to m in this case. So we easily get 9m. As we put m in place of 3q cube, then we get our result. Okay, then let's move to next, and that is case 2, where r equals to 1. Then our expression is 3q plus 1 for x in this case. So let's convert it into cube. We get x cube equals to 3q plus 1 whole to the power cube. And after taking out the cube of this expression, we get 27 q cube plus 1 plus 27 q square plus 9q. Then let's take 9 common out from this expression. Then what we get? We get x cube equals to 9 in whole bracket 3q cube plus 3q square plus q whole bracket close plus 1. Okay, now let's take 3q cube plus 3q square plus q in whole bracket as m and place it beside 9. So we get 9m plus 1. So this expression is proved. Let's see case 3, where r equals to 2, then our expression is 3q plus 2 for x in this case. So let's convert it into cube. We get x cube equals to 3q plus 2 whole cube, and after taking out the cube of this expression, we get 27q cube plus 54q square plus 36q plus 8. Then let's take out 9 common out from this expression. Then we get x cube equals to 9 in whole bracket 3q cube plus 6q square plus 4q plus 8. Okay, now let's take this expression, which is 3q cube plus 6q square plus 4q whole bracket, as m, and place it beside 9. So we get again 9m plus 8. So the expression is again proved. Therefore, all the three cases explained above, it is proved that the cube of any positive integer is of the form 9m plus 9m, 9m plus 1, or 9m plus 8. Let's see another example. Use Euclid division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. We have took x as some positive integer and y equals to 3. Why we took y equals to 3? Because there is only 3 possible steps to solve these expressions. So we will use the Euclid division algorithm over here. So I think so you all know the basic formula of Euclid division, and that is bq plus r, where q is greater than equals to 0 and r would be less than b. And here our b is 3, our y is 3, right? So r will be our what? 0, 1 and 2. So our expressions will of x will be what? 3q plus 1 and 3q plus 2. Why 3q plus 1, 3q plus 2? Because we are adding the remainder at the back. Now, as per the questions given, by squaring both the sides, we get x square equals to 3q whole square, and that is 9q square. And we will take out the common, and the common from here, that common is 3. And 3q square we will take as m. Okay, then after putting it behind of 3, we will easily get 3m, right? Hence the equation is proved that x square equals to 3m for our first equation. Let's solve the second equation, that is 3q plus 1 whole to the power square, and after making it square, we will get 9q square plus 1 plus 6q. And after taking out the common of 3 from this equation, we will get 3 in whole bracket 3q square plus 2q bracket close plus 1. And in and let's take 3q square plus 2q as m to get the result 3m plus 1, because in the place of 3q square plus 2q we will put m to get the result. Let's see again the third equation. Same, put the value, take the common out, and again after taking out the common, we will get 3q square plus 4q plus 1 in a whole bracket plus 1. Okay, so again we got the same equation, that 3q square plus 4q plus 1 equals to m to get the result 3m plus 1. Okay, so hence from the equation 1, 2 and 3, we say that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. That's it for today, guys. If you like my video, then please like, share and subscribe my channel. Hit the bell icon for regular update. And if you doesn't understand anything, then please comment it below. I will definitely help you. Till then, take care, stay safe, stay healthy. See you soon on my next video.